Hi, welcome back to Math with Mike. So, today we're going to start factorials and combinations. So, what is a factorial? Factorial looks like this. Alright, so this is something we see in math that we're going to see more closely towards statistics, which can get pretty complicated, right? So this 5 factorial, the factorial expression can be generalized to the factorial of an arbitrary natural number n as. So, that being said, this is the formula. N factorial equals n times n minus 1 times n minus 2 times n minus 3 times n minus 4 dot 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 all the way to n minus x, right? So up here, what do we have? 5, you have the 5, so that's the n. 5 minus 1 is 4. 4 minus 1 is 3. 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0, but we don't have to put that. And then when you multiply all these together, we'll get 120. So that's the factorial 5. Let's try the factorial of 30, right? So 30 factorial. So basically, we have 30 times 30 minus 1. 30 times 30 minus 1 is 29 times 28 times 27 times, and it's all minus 1 up until you get to 1. And in this case, you multiply all these out and you'll get your answer. We won't, partly because I don't have a calculator with me and I'm not going to do all these numbers like that. But later on, we'll see that there's an easier way to get to the answer. So, that is one type of factorial. The next type of factorial is a fraction factorial, which you could see. 8 factorial over 3 factorial. So, this equals 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 3 times 2 times 1. 3 times 2 we know is 6. And then all the ones at the top would be 7 times 7 is 49, plus 7 is 56, times 6, times 5, times 4, times 3, times 2. Altogether, final answer, 6,720. Right? So then, you can have a different type. You can have 7 minus 2 factorial equals 5 factorial equals 120. So you can do all these out so that you have the answers to all the factorials. Like 4 factorials is always going to equal to something. 3 factorial is going to equal to something. 2 factorial it's going to equal to something because it's 2 times 1 equals 2. 3 times 2 times 1 equals 6. 4 times 3 times 2 times 1 equals 6 times 4. So it's 24. And you can go all the way up, right? So you have 8. So 6 factorial, 6 times 5 is 30 times 4 times 3 times 2 times 1, 30 times 4, 120. 120 times 3, 120, 240, 360. 360 times 2, 720 times 1 is 720. That's your answer for that. All right, not so hard. Factorials, pretty basic. Let's see. Now, there's other things. So this is closer to what you're going to see in statistics. If you're taking statistics right now, you've probably seen it. N factorial over n minus 1 factorial. That's the formula. And this is n times n minus 1 factorial over n minus 1 factorial equals n. Or you might see 2n factorial equals 2 times n factorial equals 2n times 2n minus 1 times 2n minus 2 times 2n minus 3, and so on. Right? So it just keeps going. All right. I think we've gone enough over the factorials. We can go to our next portion. Here we go. This is a little more complicated, similar though. We're adding an r factorial with an n factorial. Well, dividing, but you'll see. So, basically, I'm gonna fix this paper. It's never easy with doing this with a notebook. All right, so we have n factorial over n minus r factorial times r factorial. Right? So just looking at that, we can see the first item can be located in any one of the n places. The second item can be located in any one of the remaining n minus 1 places. The third item can be located in any one of the remaining n minus 2 places. The rth item can be located in any one of the remaining n minus r minus 1 places. This means that there are n minus r minus 1 equals n factorial over n minus r factorial arrangements. However, every arrangement is represented as r factorial times. So n factorial divided by n minus r factorial times r. This ratio of factorials is called combinational coefficient and denoted by nc base r. So nc base r. And that's what the n factorial over n minus r factorial times r factorial equals. So stuff you'll see in a lot of different statistics, coming to biology, chemistry, all that. So let's evaluate each of the following. So we have 6c base 3. So what would that equal? So if n is 6 and 3 is r, we'll have 6 factorial over 6 minus 3 factorial times 3 factorial. Right? So we know from over on the other page that 6 factorial equals 720, and 3 factorial 3, because it's 6 minus 3 is 3 factorial. So 3 factorial, 3 factorial. So that's 6 times 6, which equals 36. So 720 divided by 36 is 20. So for the next one, we'll do 7c base 2. 7 factorial over 7 minus 2 factorial. It's 2 factorial. And then we will get 7 factorial or 5 factorial, because 7 minus 2 is 2 factorial. 7 factorial is 5040, and 5 factorial, 2 factorial is 120 times 2. See how it makes it easier when we do it? We do all the factorials that we might need out first, and then we come back and we can start doing combinations. These are called combinations. C represents. So basically, pretty simple. We can move to a stranger one, and it's something you might see. We'll finish this first though. So 5040 divided by 240 equals 21. So we have 3 combination 0 equals 3 factorial divided by 3 minus 0 factorial, 0 factorial. And this equals 3 factorial. 3 minus 0 is 3, so we'll have 3 factorial, 0 factorial. 3 factorial over 3 factorial goes 6 divided by 6. 0 factorial is 0. Or just, there's no factorial to use in it. So 6 divided by 6 is 1. There's your answer. So next, we can move in even to a harder form of this. And this prepares us for the Pascal series, right? And the Pascal series is a little more complicated. So now we're going to look at 3 properties of combinational coefficients, right? So 3 properties of combinational coefficients. So, start here. We have n combination n equals n combination 0 equals 1. So, how do we solve this? That's the question. You might look at this and you'd be like, wow, that looks like gibberish. Most people would have no idea what this means, but we do. So, that's what we're going to study. So, n combination base n equals n factorial over n minus n factorial n factorial. So it's the same basic thing that we did up here. So this would equal n factorial over 0 factorial n factorial equals n factorial over n factorial, since that is nothing, pretty much. And that equals 1. And we also have to look at n combination 0. N factorial over n minus 0 factorial, 0 factorial equals n factorial over n factorial, 0 factorial equals n factorial over n factorial equals 1. So they both equal 1. Right? And then we're going to start one that's a little more involved. So we'll do n combination n minus r, which equals n combination base r equals n factorial. See how long these get? N minus bracket n minus r factorial, n bracket and parentheses factorial n minus r factorial. And then to break that down even further, we have n factorial over, and this will look different once we put variables in it. Or once we put numbers in it. So, or integers to be more correct. So n minus n plus r factorial, n minus r factorial, right? And then we break it down even further, n factorial over r factorial, because the two n's cancel. And we have n minus r factorial, and this equals n combination r. So we found that n combination n minus r equals n combination r because the n's down here cancel. It's pretty cool. All right, so why don't we try adding some numbers in here? So how about we do 3 combination 1. So we have 3 factorial, 3 minus 1 factorial, 1 factorial equals 3 factorial over 2 factorial for 1 factorial. And 3 times 2 is 6, divided by 2 times 1 is 2. You'll get 3. All right. Thank you for the lesson on combinations. The next lesson will be on binomial series. Hope this helps with your question. Have a great day.